Hello. How is everybody? Okay. I'm just going to go over a few multiple choice questions. If you feel like you have more that you want to go over, let me know. I'm going to go over, I think, let's see, it looks like one. I'm going to go over number 2, number 5, and number 6 for right now. Okay. 2, 5, and 6. All right. Then if you have more, let me know. Okay. So let's go and capture the main screen and we're ready to go. Okay. All right. Number 2. Let's take, whoops, sorry, down here. Forgot I have to use this right here. Okay. 35 people from a random sample of 125 people, workers from company A, admitted to using sick leave when they weren't actually ill. Okay. So we have right here. Let's go and just annotate this right here. Because if you see right here, let's see, so we're going to say right here that we first have 35 people right here out of 125 admitted to using from company A. So I'm going to say P hat of company A is 35 over 125, right? And that's going to come out to B right here. 35 over 125 ends up giving a value of 0.28. Very good. Next, we have P hat of company B. P hat of company E, 17 employees from a random sample of 68 workers. 17 over 68, which gives me right here 0.25, okay? Admitted they'd used sick leave when they weren't ill. Which of the following is a 95% confidence interval for the workers in the proportions of workers for the difference in the proportion of workers at the two companies who would admit to using sick leave when they weren't ill. Okay, geez, very terrible. Using sick leave when they weren't actually ill. Anyway, right here. All right, so if you take a look at this, first of all the choices that you have, A, B, C, D, and E all have 0.03 as the statistic, right? So plus or minus, and then what do you have next? If we're talking about a difference of two proportions, the Z star value. Okay, in this case, for a 95% confidence interval, all right, sorry, that's just my dog whining on the other side right here. That's going to end up being right here 0.025 right here, and that will give you a value of negative 1.96, which up here will be positive 1.96. So my Z star value will be 1.96. Okay, so that gives me B, D, or that's it. Okay, either B or D are the possibilities, right? E gives me that, so that can't be it. C can't be it, right? And obviously A is not it. All right, so it's between B and D. Let's take a look here. Okay, so we have, first of all, right here, if you look at the formula right here, the actual formula, okay, let me go and just go to the summary right here. Here's the formula that we're using right here. It's going to be right here. We're talking about a confidence interval, right? So it's going to be P hat sub 1 times 1 minus P hat sub 1 over N sub 1. P hat sub 2 times 1 minus P hat sub 2 over N sub 2. So no problem. All right, let's go back to where we just were. All right, and there we go. So P hat sub 1 is 0.28, and then 1 minus 0.28 is 0.72 over N sub 1, which is 125. Looks good right there. This is going to be 0.25. 1 minus 0.25 is 0.75 over my N sub B value, right, or N sub 2, whatever you want to call it, 68. B looks like the winner. Okay, if you look at C, the sample proportion values are way off. Anyway, okay, so that was number 2. Very good. All right, I know I'm going a little bit fast here. I just want to make sure I get through this without the video being like 800 minutes long. Okay, so let's go to number 5. We'll do 5 and 6. All right. Let's see here, 5. Okay. So if you look for 5, it says, what's the correct standardized test statistic? Okay. So what's the formula right here for standardized test statistic right here? Okay, don't forget about that. So in this case right here, the formula is, let me just write that down, Z equals, okay? And right here, we're talking about, first of all, the x bar sub 1 value minus x bar sub 2 value minus 0 all over the square root of right here. And then we say, first of all, the, let's see, here's the sample standard deviation. So that's going to be S sub 1 squared over N sub 1 plus sample standard deviation sub 2 squared over N sub 2. Okay, so let's see what we have here. We can just annotate this. I think we'll be all right. Okay, so it looks like right here. Right here, let's read the problem. Researchers wanted to compare the average amount of time spent in extracurricular activities by the high school students. Okay, let me just increase this so I have a little room to write. In a suburban school district, with that in a school district in a large city, like an urban school. The researchers found right here for a simple random sample of 60 high school students in a suburban school, right? So N sub S is 60. Found the mean time spent in extracurricular activities per week to be 6. So X bar of S equals 6. Standard deviation right here, is S sub S is going to equal 3. All right, and then what's our other information? Researchers also obtained an independent simple random sample of 40 high school students in a large city school district. Let's call it urban, okay, or city, whatever you want to say. They use the word city, so that's fine. So I'm going to say right here, 40, so N sub C equals 40. Okay, and it looks like right here, they spent a mean average time of 5 hours right here for extracurricular activities. So right here, that's going to be X sub C equals 5. And S sub C, standard deviation, is going to be 2. Okay, so we just have to go and fill out the formula right here that we have. Okay, so first on the top, X bar 1 minus X bar 2. That's obviously just going to be 6 minus 5. All right, that doesn't help us at all because you see all the answers do have 6 minus 5 here. Okay, so let's look at the denominator right here. So sample standard deviation squared, obviously it's not A. Okay, and it's not C, all right, and it's not D, so it's only between B and E right here. So it's going to be right here. First sample standard deviation we have is 3 squared over our N value, which is 60, check, plus right here, it looks like we have 2 squared over our other N value, which is 40, check, okay? So why is this one better? There must be something about this one that's not like this one. So they are, oh, wait a second, they really tried to trick you. So I looked at everything right here, but look what the problem is. One of them is Z, the other one is T. Okay, we're not talking about Z right here. We're getting, this is the mean. So we're talking about a two-sample, we're talking about a two-sample T-test for the difference in two means, right? So B is out of there, and the answer is going to be right there. Here we go, E. All right, E is the correct answer because it's the T-score that we're getting. Okay, all good. So that was a little tricky at the end, but we got it. Let's look at number 6. Okay. Oh, this got cut off a little bit. Sorry about that. The p-value for the test is 0.048. A correct, I'm just going to read it from my book. Hopefully you have it right here. The p-value for the test is 0.048. A correct conclusion is 2, right here. Okay, so let's think here. First, right here, the p-value is 0.048, right? So that is right here less than alpha equals 0.05. Okay, so we are going to right here, and if the alpha is 0.05, which it looks like all these options is, we are going to reject the null, and we have convincing evidence. All right, for the alternative, for H sub A. I'm just writing down a note. So that here, no, not failed direct, no, not failed direct, no, not failed direct. All right, it's between D and E right here. Yes, we're going to reject the null because 0.048 is less than alpha equals 0.05. There is not convincing evidence. Uh-oh, no, there's definitely convincing evidence. Not D, so it must be E. All right, there is convincing evidence of a difference in the average time spent on extracurricular activities by students in the suburban and city school districts. So it is E. Okay, So all good right there. All right. If you have other questions besides these three, let me know. All right. And I will put them up periodically, but this should be good for right now. Hope everyone is actually doing well. Just want to make sure I have a great weekend. Stay safe. All right. Find something to do in the house and have fun. Okay. Have a good day, guys. See you later.